Okay, today's date is 1/31/14, and today's lesson is called Using Proportional Relationships. And the first thing we got to talk about is indirect measurement. So indirect measurements is used for measuring things like tall buildings, because you can't really climb on top of the building and then drop the measuring tape and go, hey Tom, what does it say at the bottom? So indirect measurement is used for that reason, to measure things that are impossible to measure with a measuring tape. So the definition of indirect measurement is it's a method that uses formulas comma, similar figures, comma, and or proportions to measure objects. So it's a method that uses formulas, similar figures, and or proportions to measure objects. So now here's an example of something like that. Tyler wants to find the height of a telephone pole. He measured the pole's shadow and his own shadow and then made a diagram. What is the height of the pole? Okay, so we have these measurements shown on here, and we need to set up a proportion. But first, let's convert the measurements into a single measurement. We have 5 feet 9 inches. We need to convert that to all inches or all feet. Well, it's easier to go from feet to inches. So 5 feet 9 inches. There are 12 inches in a foot, so 5 feet is 60 inches plus 9, that's 69 inches. 7 feet 8 inches, that's going to be 7 times 12, 84 plus 8, 92 inches. Then we have 38 feet 4 inches, that's 460 inches. Okay, and now we can set up a proportion. We can say that 92 is to 460, the same thing as 69 is to h. So that's what we're going to write. 92 over 460 is equal to 69 over h. So now we cross multiply. 92 times h is 92h equals 460 times 69. So 92h equals 31,740. Now divide both sides by 92, and we get h equals 345 inches. Now, we're not going to give that as a height of a pole. We're not going to say, oh, that pole is 345 inches. So let's turn that back into the proper measurement. So we're going to take 345 and divide that by 12, and we get 28.75. So I know that's 28 feet. Now, what's 0.75 of a foot? So we're going to do that over here. 0.75 times 12 is 9. So the answer is 28 feet 9 inches. Okay, this is as complicated as it gets. Okay, let's look at the next one. On a Wisconsin road map, Kristen measured a distance of 11 1/8 inches from Madison to, I guess, Wausau. The scale of this map is 1 inch to 13 miles. What is the actual distance? Okay, so you take your given 1 inch to 13 miles. So you write 1 inch over 13 miles equals, it tells you there's a distance of 11 1/8 inches. So inches go on top. So you put 11 1/8 over x. Okay, so you cross multiply. 1 times x is 1x equals 13 times 11 1/8. So x equals 144.625. And the question says, what is the distance to the nearest mile? So the answer is going to be 145 miles. Okay. Let's look at number 3. Lady Liberty holds a tablet in her left hand. The tablet is 7.19 meters long and 4.14 meters wide. If you made a scale drawing using the scale 1 centimeter to 0.75 meters, what would be the dimensions to the nearest tenth? So you start with this, your actual scale given. So you write 1 centimeter over 0.75 meters equals. Okay, it says the tablet is 7.19 meters long. So is that going to go on top or the bottom? Well, it says meters, so meters go on the bottom. So 7.19 meters and x on top. So you cross multiply. 1 times 7.19 is 7.19 equals 0.75x. Now you divide both sides by 0.75. And you get x equals 9.6 centimeters long. Okay, we need to do that for the other dimension too, because we need to know how long and how wide it is. So you start with the same scale, 1 centimeter over 0.75 meters equals, it tells me that it's 4.14 meters wide. So meters go on the bottom, 4.14 meters, and then x on top. So we cross multiply. 1 times 4.14 is 4.14 equals 0.75 times x is 0.75x. Now you divide both sides by 0.75. And you get x equals 5.5 centimeters, and this is going to be wide. So that's your answer. It's going to be 9.6 centimeters long and 5.5 centimeters wide.